here comes the second law. It says a to the power 0 is equal to 1. A to the power 0 is equal to 1. A can be a number in any form, which means any number raised to the power 0 is equal to 1. Whether it is 1 million or 2 million, whether it is just 2 or 1, whether it is 5 or 10, just anything at all that is A raised to the power 0, the result is equal to 1. How are we sure that this is true? That takes us to the proof. Let us prove that this statement is correct, mathematically speaking. Permit me to use this number operation to prove that this statement is correct. 2 to the power 2 divided by 2 to the power 2. Traditionally, what we're required to do is to get the value of this in its ordinary form and get this one in its ordinary form. Then divide this by this. Whatever we get is the answer if we are correct in that division. Now, this means this over this. So that next we have 2 to the power 2 is 2 times 2. I hope you agree. Then 2 to the power 2 is also 2 times 2. Therefore, 2 to the power 2 divided over 2 to the power 2 is equal to 2 times 2 over 2 times 2. 2 times 2 is 4. 2 times 2 is 4. It means 4 over 4. When a number divides itself, the result is 1. Therefore, 2 times 2 over 2 times 2 is equal to 1. I hope you are following the argument. What it means, therefore, is that it is this number operation that produced 1 as the answer. That is 2 to the power 2 divided by 2 to the power 2. That is this thing here. Is equal to 1. Again, we look at alternative method of getting the correct answer to this operation. Applying a law already known, that is law number 1, under this law of division is applicable here, since we have seen before that first law under law of division and derivatives is valid. We can as well extend it to solving this one. 2 to the power 2 divided by 2 to the power 2. Let's apply it. That will give us 2 raised to the power this minus this. Do you recall? Do you recall that this is in obedience to the first law under this subheading of law of division and derivatives? You should remember. Then applying it, 2 minus 2 is equal to 0. Therefore, 2 to the power 2 divided by 2 to the power 2 is equal to 2 to the power 0. This is a correct way of carrying out the evaluation of this number process. Also, we conclude that 2 to the power 2 divided by 2 to the power 2 is equal to 2 to the power 0. We now have 2 results from 2 operations. From this number operation, we have this result. From this number operation, we have this result. Both of them are valid. It means that this is correct and this is also correct. What can we get from here? Let me again remind you of logic that will help us draw a conclusion. And there comes that logic. It says if A is equal to B and A is also equal to C, it follows that B is equal to C. Think about it. There exists a number. As long as it is A, if A is here and A is here, the two of them don't have a different value. If we have different symbols here, it means that they stand for different values. But because we have A here and we have A here, it means that what A is here is what A is here. If A is 5, then the same 5 is here. If A is 10, the same 10 is here. As long as the same symbol is here and here, it means that the value of A here is the value of A here. I hope that is clear to you. So if that A is equal to B and A is also equal to C, the implication is that this and this are also equal. That is why I said B is therefore equal to C. Now, let us adopt this logical reasoning in drawing conclusion from these results of number operations. 2 to the power 2 divided by 2 to the power 2 is equal to 1. The same 2 to the power 2 divided by 2 to the power 2 is equal to 2 to the power 0. This and this are like saying A and A. The same thing, the same operation is here, the same operation is here, but they give us different answers. The same way we have different things, B and C. As long as the same operation gives us two different answers, those two different answers, though they appear different, are equal in value. This is what takes us to the conclusion that this is equal to this or this is equal to this. That is to say that since this is equal to what you have here and the same thing is equal to what you have here, it means that 2 to the power 0 is equal to 1. 2 to the power 0 is just a case in point. This is applicable to every other number raised to the power 0. After all, is it compulsory that in proving this, that 2 must be used? It could have been 5 or something else that I used. So 2 is just a case in point. Because of that, any other number raised to the power 0 is equal to 1. That's why I said any other number, which is this A, raised to the power 0, is equal to 1. Let's see examples that confirm this law. Examples are here. The first one, 5 raised to the power 0 is equal to 1. Don't forget that A can just be any number at all. Whether a constant or a variable, A represents any number in any form at all. In this case, our A is 5 raised to the power 0. The answer is equal to 1. This is a variable, x to the power 0 is equal to 1. We don't know what x is, but whatever it is, raised to the power 0 is equal to 1. What about this? A has taken a form of 3x, but it is raised to the power 0. So whatever is here, as long as we have raised to the power 0, the answer is equal to 1. The last example, number D, highlights a point. What is it? Let's get the answer first, before the point. 7 bracket x to y raised to the power 0 is equal to 7. Why is this one not equal to 1? It is because this power 0 does not apply to 7. If 7 is enclosed along with x and y in this bracket, then this 0 would have been able to affect it or influence it and determine its outcome. But because this 7 is outside the bracket and only xy has this bracket, so this 0 does not determine what happens outside this bracket. Instead, it only moderates the outcome of this bracket. So xy alone raised to the power 0 is 1. Then 7 times 1 is equal to 7. I hope these examples make sense to you. Now, find out if you can tackle the following. And here comes the checkpoint. It says, evaluate the following using the law a raised to the power 0 is equal to 1. The first one is 3 to the power 0. Second, as number B, is 3 times 2 to the power 0. Number C is 3 to the power 0, x to the power 2. Number D is 4 bracket x to the power minus 1, y to the power minus 1, z to the power minus 1, all to the power 0. Now let's see law number 3 under the subheading, law of division and derivatives. And this is law number 3. It says a to the power 1 is equal to a. Any number raised to the power 1 is equal to that same number. How do we know? Let us see a proof. Permit me to use this number operation to prove that this statement is correct. 3 to the power 3 divided by 3 to the power 2. First, it is equal to this divided by this. That is 3 to the power 3 divided by or over 3 to the power 2. We recall that 3 to the power 3 means 3 times 3 times 3. We also recall that 3 to the power 2 is the same thing as 3 times 3. Therefore, this expression is equal to this expression. If we carry out the traditional operation on these numbers, what we see at last is 3. What it therefore means is that this operation is equal to 3. The summary is here. That is, this operation, which is here, is equal to this 3. See it here. Therefore, 3 to the power 3 divided by 3 to the power 2 is equal to 3. Let us carry out the same number operation by applying law number 1 under this section, the law of division of numbers in index form. That is what we want to apply. Don't forget that this one was done with just the traditional method of division of numbers in their ordinary forms. Let us apply the first law of indices under the law of division, and this is it. 3 to the power 3 divided by 3 to the power 2. Based on that law, it gives us 3 to the power 3 minus 2. That is this minus this. 3 minus 2 is equal to 1. Therefore, we also conclude that this number operation, which is the same thing as this number operation, is now equal to 3 raised to the power 1. I hope you know where this 1 came from. 3 minus 2 is equal to 1. We therefore summarize that this equal to this. See the summary here. Since this operation gave us this, and the same operation gave us this, by that same logic, let us again remember that logic that enables us to make a conclusion. Please watch out again. It says, if A is equal to B, and the same A is equal to C, you may ask, is it possible for one thing to be equal to different things? Anyway, this is logic. It is not possible for one thing to be equal to different things, even if different symbols are used. But one thing is equal to those different symbols. For the fact that one thing in real life, one number, can't be equal to two different numbers. There is no way A can be equal to B, and the same A is equal to a different thing. It is impossible. If the statements are correct, then these two must be equal, because the same A, the same number A, cannot be equal to two different things. A given number has equal value everywhere. So if this is equal to this, and this is equal to this, then this must be equal to this. This is our conclusion. Likewise, if this is equal to this, and this, the same thing, is equal to this, it thinks that this and this are equal, leading us to a conclusion that 3 to the power 1 is equal to 3. It could have been something else. It could have been a different number that I used for this proof. That I adopted 3 is just circumstantial. It could have been 5 or something else that I used to prove this point. But because 3 is used, I am going to make a conclusion with 3. Therefore, adopting a different approach, we now say that A to the power 1, where A now represents anything else, is equal to A. Therefore, a number raised to the power 1 is equal to A, confirming the earlier statement made here before. Now, let's see some examples of operations that conform to this law. And here come about 3 examples. The first one, that's number 8, says 5 to the power 2 times 5. What is it going to be? This 5 has no power on top of it. But we recall that based on this law, whenever a number is written without any power on top, the actual power on top should be 1. What it means is that we can rewrite this 5 as 5 to the power 1. Is that clear? Now 5 to the power 2, which is this one, times 5 to the power 1, now gives us a structure that will make us conform to the first law of indices under multiplication of numbers and derivatives. What will it be? We add these two. 2 plus 1 is equal to 3. We then have 5 raised to the power 3 as the answer in index form. We multiplied numbers which are found in the index forms and we got the answer in index form. Second example, that example B, says 7x to the power minus 3 times x. Again, we see a case in which a participant, that is this x, is written without any number written as its power. That is why we're going to go back to our law to recall that when a number is written without any power written above it, the actual power it has is power 1. So like before, we're going to write this x as x to the power 1. That takes us to 7x to the power minus 3, which is now here, times x to the power 1. This makes us apply another law we have known before, a law of multiplication of indices. But there is a particular law under that, its derivative, that will help us simplify this. And then that takes us to 7x to the power minus 2. 7 times 1 is 7. X raised to the power this plus this. Minus 3 plus 1 will give us minus 2. So the answer to this operation is equal to 7x to the power minus 2. The next is this C. Y times y to the power minus 2 times y. If you watch this y and if you watch this y, you discover that there is no power written against each of them. But we know that if we refer to this law, we still have 1 here, we still have 1 here, giving rise to y to the power 1 times y to the power minus 2, which is here, then times this y to the power 1, which was here before without a power. Now it has become clearer, and we can now apply the law we have learned earlier, one of the laws we learned earlier, the law of multiplication of indices, not even its derivative. That takes us to adding these indices, 1 plus minus 2 plus 1. So that will give us 1 minus 2 plus 1. I hope you know what the answer is 0. I have 1, I'm owing 2, I have 1. So what you have is 2, and what you're owing is 2. So you pay in the end, you have 0. Therefore, the whole thing will give us y to the power 0. Doesn't end there. We recall that any number at all raised to the power 0 is equal to 1. So the answer is equal to 1. So the entire operation here is equal to 1. Now check whether you can apply what you learned here in solving what follows. And here comes the checkpoint. It says, evaluate the following operations, recalling that a to the power 1 is equal to a, where necessary. The first one says 3 times 3 to the power 2 times 3. Second one says b to the power minus 1 times b times b to the power minus 1 times b. C is m divided by m to the power 5, and d is d to the power 7 divided by d. Now let's take another law.